Good morning. This is Dr. N. Ramya, Assistant Professor from Civil Engineering Department. Today, my lecture is on a laminar boundary layer problem number 2 in hydraulic engineering. So here we have derived a previous session. What is that? U by capital U is equal to 2y by delta minus y square by delta. This as we have derived. So similarly, now we are deriving. Now we are finding what is the boundary layer thickness and shear stress, local coefficient of drag, and coefficient of drag. These all things deriving for velocity laminar boundary layer in velocity distribution in the laminar boundary layer. That is what U by capital U is 3y by 2 delta minus y cube by 2 delta cube. That is equal to small u by capital U. So 3y by 2 delta minus y cube by 2 delta cube. Right? For this, we have to calculate what is delta, what is shear stress, what is local coefficient of drag, and what is average coefficient of drag or coefficient of drag. These all things we are going to find out now. Yes, what is the given equation? It is given equation U by capital U is equal to 3 by 2 into y by delta minus y cube by 2 delta cube. This is the given equation. And already we know von Karman momentum equation is what? Tau naught by rho u square is equal to d theta by dx. What is theta here? Theta is integration of 0 to delta small u by capital U into 1 minus u by capital U into dy. This is what your momentum thickness equation is. Yes. So before that, here we need to know the value delta. To calculate shear stress and drag coefficients, we need to know the delta value. So here, to find out the delta value, we are taking this value, this one, to calculate. We are substituting small u by capital U value in place of this and this. What is small u by capital U? Small u by capital U is 3y by 2 delta minus y cube by 2 delta cube. Y cube by 3 delta 2 delta cube. Right? We are substituting this value in place of y by u by capital U. Right? So here I have substituted, and here also in place of this u by delta capital U value is placed. For this, we are taking out all things outside bracket. We are removing here 3y by 2 delta minus y cube by 2 delta cube, as similar as written here, 1 minus 3y by 2 delta, and here plus become, here it is minus because minus into minus is plus. That's why here we are written plus y cube by delta 2 delta cube. Yes, after getting this, we are multiplying each and every term here as done for before one. First we are taking 3y by 2 delta. We are multiplying with 1, and next 3y by 2 delta, and next y cube by 2 delta cube. After that, again this term is multiplying with 1, and second term and third term. That is done here. Yes, what we got here? 3y by 2 delta minus 9y square by 4 delta square plus 3y to the power of 4 by 4 delta to the power of 4 minus y cube by 2 delta cube, 3y by 4 delta to the power 4 and y to the power of 6 and by 4 delta to the power of 6. These all things has got from above multiplication, right? From one term to other terms, right? So now here what we are doing, we are removing the integration with x. We are integrating with respect to y here. So when you integrate, you will get 3y by 2 delta will become 3y square by 2 into 2 delta. Yes, that is what 3 by 2 is common. You are getting y's integration of y as y square by 2. So here y square by 2 delta. Here also in place of 9y square, y 4 delta square. So here when you integrate y square, you will get y cube by 3. So y cube by 3. Here to the power of 4, here to the power of 4, that is y to the power of 5 by 5. And y to the power of y cube is becoming y to the power of 4 by 4. Yes. And here also y to the power of 5 by 5. 5, 5. And here y to the power of 6 is becoming y to the power of 7 by 7. Right, and leftover things are like that only. 4 delta 6 is same. So these are all we have integrated, and the limits are 0 to delta. Limits are 0 to delta. Here we are taking a value y is equal to delta and neglecting the 0 value because it is 0. So here 3 delta square y, substituting just y here, 3 delta square by 4 delta minus 3 delta cube by 4 delta square. See here, in place of y just we are substituting this delta, that's it, delta delta. So you will getting 3 delta to the power of 5 by 20 delta power 4 delta 4 delta cube delta 5 delta 4 and delta 7 delta 6. These are all the same values we got here. So after getting this you will getting cancel here. All these values are getting cancelled. So what we are getting here, 3 by 4 delta minus 3 by 4 delta, 3 by 20 delta minus 1 by 8 delta plus 3 by 20 delta minus 1 by 28 delta. These are the values we are getting, right? So this 3 by 4 delta plus and minus will getting cancelled, and same here plus is becoming 6 by 20 delta minus 1 by 8 minus 1 by 28 delta. So when you simplify this, you will get LCM as 280. When you do 28 and 28, you will get LCM as 280. So 280, 84 minus 35 minus 10. Right? These are values we will get. So what is the overall value? When you simplify, you get 39 by 280 into delta star by delta x. That is what your tau value is, tau by rho u square value. Yes, I need only tau square, tau naught. So I am shifting all these terms to right hand side, rho u square, 39 by 280, dou delta by dou x. So that my equation has become 39 280 rho u square dou delta by dou x. Right, this is what you got. After getting these value tau naught, again we have to do the another tau naught by using Newton's law of viscosity. According to the Newton's law of viscosity, tau naught is mu into du by dy, where your y is equal to 0. So here already we know term u by capital U is equal to 3 by 2 into y by delta, 3 cube by 2 delta cube. Right? So here I am shifting this u to right hand side, and now I am differentiating this u with respect to y. Du by dy is equal to u is constant and 3 by 2 delta. This will become 1 when you differentiate, and this will become y square by delta cube. So y square by delta, only y square, y cube, it is y square, sorry. Y cube, yeah. So y square by 2 delta cube. right? This is what we got here. So when you substitute in place of y is equal to 0, you will get only 3 by 2 delta. 3 by 2 delta into u. 3u by 2 delta. 3u by 2 delta. So that for this complete value is 3 by 2 mu capital U by delta. Complete tau naught is. Complete tau naught is. Now we are equating this second equation, and before it is one equation. Huh? This one equation and equation 2 we are equating to get delta value. So what we are getting here, delta into d delta, that is equal to all terms to the right hand side. So that you are getting 240 by 339 mu by rho u into dx. Right? So when you integrate this equation, you will get delta square. Integration of delta d delta is delta square by 2, that is equal to 420 by 39 mu dou x plus c. Integration, that is constant. Integration, constant of integration, c. So here again same here, we need to calculate c value. So that I am taking condition x is equal to 0 where your boundary layer is also 0. Where x is equal to 0, your boundary layer also is 0. So when you substitute these two values, you will get c is equal to constant in this equation. So substitute the c value in that equation, you will get only this term. Yes, this term. Now you delta is equal to root of 420 by 39 into 2 mu by rho u into x. Yes, this when you do it, you will get 4.64 root of mu x by rho capital U. Right, that is equal to 4.64 root of mu x into x. I am multiplying again x to get in terms of Reynolds number. In terms of Reynolds number, I am multiplying x in numerator as well as denominator. So that my equation has become complete. 4.64x by root RE. So 4.64x. The delta is 4.64x by root of REX. Right? I need here to calculate. 1 second. You got here delta as 6 point delta. So I am substituting this delta value in previous equation. Delta value in this equation 2. Yes, in this equation 2, which we got from the Newton's law of viscosity, right? 3 by 2 mu u by delta, this equation. So in place of delta, this equation we got. So here in this equation I am substituting delta. This equation we got by Newton's law of viscosity, right? So I am substituting this delta value in this equation. So that tau naught is becoming complete 0.323 mu u by x into REX. This equation I got when I substitute delta value in Newton's law of viscosity. Right? Now I need to calculate a coefficient of drag. I need to calculate a local coefficient of drag CD star. This delta tau naught is also calculated. Second part is also over. Now we need to calculate third one, FD. Integration of 0 to L tau naught into B into dx. This is shear stress into area, drag forces. So shear stress already we know, this is the shear stress complete term. This one is the shear stress I am applying here, and your area is B into dx. So when you simplify this, here what we are doing, we are taking out common first this, and after the solve these terms, and also I am reviewing this RE. I am splitting this. RE is what? Rho u x by mu. I am splitting here and taking all constants on before the integration. I need only the 1 by delta x dx integration term 0 to L, and all other terms I have taken as a constant. So this is what a constant terms, and this root x is become when you take to numerator, it is becoming x to the power of 1 by 2. 0 to L x to the power of 1 by 2 dx. So this what happened, x to the power of 1 by 2, when you integrate it will become x 1 by 2 by 1 by 2 into limit 0 to L. So when you substitute y is equal to L, you will get this equation. What is that? 0.323 into 2 mu u into root of rho u mu into b into root L. Yes, this is the equation. Complete equation when you make it. Now drag coefficient. Local drag coefficient. Only coefficient of drag or average coefficient of drag. This is the value is what? CD. This is CD star value. CD. So here we need FD by rho A U square. We know already FD. We got this 0.646 mu U into root rho U L by small mu into B. Mu into B. Right, and here half rho. This BL is your area. B into L into U square. Capital U square. So when you substitute here and simplify, you get this 1.292 by root rho u L by mu. So we know already rho u L by mu is root RE with respect to L. So this is coefficient of drag CD 1.292 by root RE L. Right? This is what we got for coefficient of drag. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.